Hi, welcome to the ECOD software product demonstration. ECOD is the first unit operation for AspenTech's HYSYS simulation environment written specifically for modeling a turboexpander compressor. ECOD rigorously calculates design and off-design performance for an expander compressor within the HYSYS environment. ECOD can be used for rating studies of existing equipment, off-design calculations for expanders during the plant design phase, and what-if studies for new processes. ECOD was written by Steve Chafin, consulting process engineer for River City Engineering, and Grant Nordwall, senior machinery engineer for Moffitt Trench Corporation. Without ECOD, HYSYS expander and compressor unit operations cannot automatically determine the off-design performance of a turbo expander. This simulation shows an expander plant model with a separate expander unit and compressor unit operation. Notice that the power is linked between the expander and compressor, and so the simulation will have the correct energy balance. However, real-world turbo expander performance is fundamentally related to the machine speed, which changes with process conditions. With the modeling approach shown here, the user must determine the expander and compressor performance outside of HYSYS and manually enter these results into the simulation model. The simulation must be interrupted to perform this manual iteration. With ECOD, the expander compressor becomes a single unit operation, as shown in this plant model. ECOD provides three modes of operation. Generic mode allows a relatively accurate simulation to be run when little or no expander compressor information is available. This is useful when doing initial design work in a new plant or when looking at off-design rating for an existing plant without any expander data. When an existing or quoted machine is being modeled, sufficient data will be available to run ECOD in the rigorous mode. In this case, such things as design speed, impeller diameter, and inlet guide vane area may be known. Rigorous file input mode is run when the user has obtained a data file from the turboexpander OEM and has accurate compressor performance curves, inlet guide vane area, surge point, flange sizes, and expander impeller diameter. This will give the most accurate results for modeling an existing machine and also minimizes the input required by the user. In generic mode, the ECOD unit op is placed in the simulation and the connections are made to the other equipment. Notice the radio buttons, which show the mode of operation, in this case, generic. Notice also that context-sensitive help is available on each page, with full step-by-step detailed instructions. On the connections page, note that the expander JT bypass and compressor recycle are built into the ECOD module. This allows for a reasonable operation over a variety of flow conditions. When the expander flow exceeds the inlet guide vane capacity, flow is diverted through the JT valve. When the compressor through flow drops below the surge control point, flow is recycled as it would in an actual plant. The expander efficiency will be approximated in the generic case based on general OEM guidelines, and compressor efficiency is set to a value of 75% as a default. When the plant simulation is at the intended turbo expander design point, the user will choose lock design parameters and set the design point for the turbo expander. Now the expander design point, compressor design point, and gas compositions can be reviewed. Note that the rigorous page inputs are empty, and there's a note that informs the user that he's operating in the generic mode. Moving to the results, you'll notice that the page is clearly labeled Mode Generic Design to remind the user that this is simply the design point. For generic mode, some guidelines are given to help the process designer set a realistic expander compressor operating point. These limits are based on OEM experience and lead to a reasonable relationship between flow and expander enthalpy, a reasonable expansion ratio, a good relationship between power and mass flow, and a reasonable relationship between expander and compressor flow. The next step is to return to the input page and choose off-design to perform ratings at off-design conditions. At this point, plant conditions can be varied from the design point, and off-design performance will be calculated and displayed in the Results tab. In generic mode, the machine frame size, design speed, nozzle area, and wheel diameters have not been determined. Therefore, the results are more approximate, and all the values on the results page are not defined. The efficiency is based on a typical off-design curve based on the estimated design point efficiency. This should be close enough for quick rating studies. The rating method is clearly labeled on this sheet, generic rating. The compressor off-design results for the generic mode are based on a typical generic compressor curve and a typical surge point. Note that the position of the recycle valve is shown as open or closed. Open simply means that some flow is passing and does not imply that it's 100% open. The compressor performance curves can also be seen. For the rigorous mode, there are two methods to input the design point for the turbo expander. The menu on this page allows the user to choose between manual input or input from file. If the user is choosing to input manually, the input pages show required data labeled input and optional inputs. While it is desirable to have the most complete information, the simulation will solve as long as all of the required fields are complete. When the user has a data file for an existing machine from the OEM, they will choose input from file. In this case, all the values for the expander and compressor design point are filled in automatically. In order to review the design point, click on Generate Datasheet on the results page. For the rigorous mode, the design point is defined rigorously, and therefore the unit operation is always running in off-design or rating mode. Shifting to the results, in the rigorous mode, more information is available in this section. The speed is now defined, the expander efficiency is based on the actual quoted or as tested design efficiency, and the compressor is based on the actual quoted or as tested head and performance. If the surge point and IGV area are known, the IGV position and the recirculation flow will be more accurate. If flange sizes are input, the actual velocities and rho v squared loss can be checked. When the OEM data file is available, ECOD is run in the rigorous file input mode. In this mode, the results have the highest accuracy and the greatest detail. Performance is based on tested curves, IGV percentage will be relatively accurate, and the recycle flow, if any, will be the most accurate. ECOD has been written with precise adherence to Maffei-Trench's off-design performance calculations. These are physically sound modeling rules which have been proven through many years of design of turbo expanders. Still, the simulation values will vary slightly from OEM off-design performance calculations. We hope you've enjoyed the demo. Please contact Maffei-Trench or River City Engineering for more information and licensing details. Thank you.